Good day, folks. Today we're going to take a look at geometric series. Now, let's go ahead and pause the video as you write down the know and do and the wicker know and do as well. Alright, go ahead and pause the video. In this slide, we are going to take a look at the difference between a series and a geometric series. In this slide, we're going to look at the difference between a series and a geometric series. Now, up to this point, we've played with series, and we've also played with arithmetic series. Today, we're going to look at geometric series. Now, let's first of all review the definition of a series. The definition of a series is just an indicated sum of the terms of a sequence. So, if we're going to look at a specific type of series, like the geometric series, it is simply going to be the series of a geometric sequence. Alright, so pause this video and write the two definitions down. In the third slide today, we are going to derive a geometric series formula. Now, first of all, let's take a look at what the geometric sequence formula was. Okay, so first of all, the general nth term of the geometric sequence, a sub n, can be written as this. Okay, so we know it's going to be the first term times r raised to the n minus 1, where a sub 1, remember, is the first term, and your r value is your common ratio. Now, if I were to expand out the geometric sequence, it would look like this. Of course, we have our first term. Then we have our first term times our r raised to the n minus 1. Well, this is the second term here, so it's going to be 1 minus 1, it's going to be 2 minus 1, which is r to the first. And then you take the first term times r raised to the, and since this is the 1, 2, third term, it's going to be 3 minus 1, or r squared, and so on and so forth, all the way to a sub 1 times your common ratio raised to the n minus 1. Now, let's take this geometric sequence and let's find the sum of it. So the sum of that geometric sequence would actually be each one of these terms added together, so it would look like what's shown right there. Now, from here, let's derive the formula. I'm going to take s sub n, and I'm going to add everything, so I have the sum of that geometric sequence. Next, I'm going to subtract from it, and I'm going to take the common ratio and multiply it times the series. And it's going to look like this. Okay, so I'm going to take r and multiply it times this, and r times this, and r times this, and so on and so forth. And then I'm going to shift it so that I have like terms on top of one another. So it looks just like this all the way to the end. Now, if I subtract this, notice what's going to happen. These are going to subtract out, and subtract out, and subtract out, all the way to the end, and all I'm going to be left with is a sub 1 here, and a sub 1 r to the n power there. Okay, so what I've just done is I have taken the series minus r times the series, and it will equal this formula right there. Now, we're going to simplify this a little bit further. Okay, we're going to start by factoring out an s sub n. If I factor out an s sub n, then I'm left with 1 minus the r. Okay, now, remember that that is equal to this right here. Okay, so I have, let me just rewrite it, I have s sub n times 1 minus r, and that is equal to a sub 1 minus a sub 1 times r to the n power. Now, I'm going to get this right here by itself. How do I do that? Well, I have s sub n times the quantity 1 minus r. So what I'm going to do is I'm going to divide both sides by 1 minus r. And when I divide by 1 minus r, this divides out, and I'm left with s sub n equaling this right here. And that is how we come up with this formula. Now, notice there's a restriction here. Why is this restriction right there? Well, if I were to plug a 1 in there, I would get 1 minus 1, which is a 0. I can't be undefined. So that's why we have to restrict it and say that my ratio cannot be equal to a 1. Okay, continuing on, let's take a look at this further. So, this explains right here what I've done. Okay, and I've already explained it up above, but this again kind of explains a little bit what we've done. Notice we factored out an S sub n, then we divided both sides by 1 minus r in order to get this formula right there. Alright, now here is our formula. Here's our formula. It says the sum of a geometric series is the sum of S sub n of the first n terms of the geometric series is given by, you have two formulas right here, or you could have this one. Now what's the difference between these two? Well, here what's happened? I factored the a sub 1 out. See, there's an a sub 1 there and an a sub 1 there, so we factored the a sub 1 out. Okay. You are permitted to use whichever one you want. Alright, so let's go see if we can use this now. Okay, before beginning here, let's go ahead and write down the formula here. Now, the formula says that S sub n is equal to a sub 1. Now, I'm going to choose to use the second formula. So a sub 1 times 1 minus r to the n all over 1 minus r. So, let's see, what do I need? I need a sub 1, I need r, and I need n. So let's go up to the series and see what I have. Well, what do I have here? Well, I have the first term. Okay, so I'm going to put that there. I look here and I can see that I multiplied by 3 to get to the next term. Okay, so my r value is a 3. And it says it wants to know the sum of the first 6 terms, so my n value is going to be a 6 as well. Alright, so let's plug that in. To find the sum of the first 6 terms, it's going to be a sub 1, which is 6, times 1 minus your r value, which is 3, raised to the 6th power, all over 1 minus my r value, which is 3. Now, 3 to the 6th, if you enter that into your calculator, is 729. So that is going to equal 6 times 1 minus 729 all over, and on the bottom I'm going to go ahead and go 1 minus 3, which is negative 2. Alright, now let's take our calculator and we're going to go 1 minus 729, and of course that gives us negative 728. Then we're going to times it by 6, and that is going to give us negative 4368 divided by negative 2. So if we divide that by a negative 2, that's going to give us an answer of, let's see, I get S sub 6 is equal to a positive 2,184. So that's the sum of the first 6 terms. Okay, so let's go ahead and check ourselves to see if we are correct, and we are, 2,184. For our second problem here, we're asked to find the sum of each geometric series, and what do I have here? Well, first of all, let's write down our formula that we're going to be using. So first of all, let's see. We have S sub n is equal to a sub 1 times 1 minus r to the n all over 1 minus an r. Do I know a sub 1? Yep, it's a 3. Do I know what my r value is? Yes, it was given to us. Do I know what my n value was? Yep, it was given to us as well. So all we have to do is plug it in. So now this means I'm finding what? I'm finding the sum of the first 4 numbers, but I wasn't given the series. Alright, we're just given, the pieces, parts of the series here. So let's go ahead and plug that in. So S sub 4 is going to be equal to 3 times 1 minus my r, which is 1/3. Now I'm going to put parentheses around that third, okay, because we're going to raise that to the 4th power all over 1 minus 1/3. Now when you enter that into your calculator, do you notice the way I put parentheses around what I raised to the 4th power? Probably pretty important that you do that so that it raises 1/3 to the 4th. Alright, so I'm going to pause this for a moment. You go ahead and grab your calculator and see what you can do in simplifying that. Okay, here's what I have when I simplified it. You had s sub 4 is equal to 3 times 1/3 to the 4th power is going to be 1 minus 1 over 81. Now, 1 minus 1 over 81, let me put this 1 minus 1/3 here. 1 minus 1 over 81 is going to be 80 over 81. Okay, that's all over. And I'm going to just put 2/3 because 1 minus 1/3 is 2/3. Now, let's see if we can clean this up a little bit here. 3 goes into there once, 3 goes into there 27 times. So that gives me 80 over 27. And I'm going to, well, when you're dividing by 2 over 3, that's the same as multiplying by 3 halves. Okay, now 2 goes into there once, 2 goes into here 40. 3 goes into here once, 3 goes into there, 9 times, and I'm left with s sub 4, or the sum of the first 4 numbers in the series is going to be 40 over 9, which is equal to what? That gives us 4 4/9. Okay, so let's go see if we got that correct. Provided I can get to... Yes, we are right. Okay, let's go practice another. Okay, on this problem, I'm only going to set it up for you, and I want you to finish it out by yourself. Okay, so first of all, taking a look here, let's see, what do? Well, we're finding the sum, and we have the first one and we have the fifth one. So that means our s sub n. And actually, I could probably say s sub 5 because we're just finding the sum of the first 5. So s sub 5 is going to be equal to our first term, which is 2, times 1 minus your r value, which is -3. Make sure you put a negative parentheses around that -3, and then you're going to raise it to the n power, and of course n is 5. And then you're going to divide that by what? Well, 1 minus your -3. Now, do not make the mistake right here of going negative and a negative makes a positive. Remember, order of operations says you need to take -3 to the 5th power first. Then take that and then multiply it times, well, then you go 1 minus whatever, that -3 to the 5th comes out to be. All right, so go ahead and pause the video, and I want you to finish it out. Okay, now that you've worked it out, you should have gotten, for an answer, 122. There's your answer. Okay, let's go on to the next problem. Okay, for this problem here, the first thing I would recommend doing is create a chart, just like what we did for the arithmetic series. Okay, so you have n, you have your a sub n, and you want to know the first 1, 2, 3, 4. So, just to give you a hint, and I'm going to let you finish this out, you're going to say 3 times what? 1 gives you 3. Then you're going to go 3 times 2, and you get a 6. And 3 times, yes, this 3, and you get a 9. And then you're going to go 3 times, and you put that 4 in there. That gives you 12. Then what are you going to do? Well, at that point, then we're going to have to add those all up. And then after you add those all up, well, first of all, it says, find me the series. So since it says find me the series, that means you're going to write them all out. So you're going to have 3 plus 6 plus 9 plus 12. And then you're going to add each of those up. And when you add each of those up, you should get this answer. Okay, we have one last problem. Now, in looking at this problem, what are we given? Well, we are given a series, and it's all expanded out. Now, they want us to put it in summation notation. To put this in summation notation, we need to, first of all, remember what do we need? We need an explicit formula. Now, remember the explicit formula. Remember, a sub n is equal to your first term times your common ratio raised to the n minus 1. Okay, so let's go ahead and find that explicit formula here. So I see that a sub n is equal to the first term, which is 1, times the common ratio, and looks like we're multiplying by 3. So it's going to be 3 raised to the n minus 1. Okay, there's our explicit formula right there. Now, from here, let's put it in with sigma notation. So in doing that, I am going to go like this, and we're going to go k equals 1 to, what do we have here? 1, 2, 3, 4, 5. So we're going to go k equals 1 to 5, and I'm going to put this formula in there. However, just like what we did for arithmetic when we went from the explicit to the summation notation, remember we changed this to a k, so it's going to be 1 times 3 raised to the k minus 1. Or you could simply just put from k equals 1 to 5, and you can go 1 times. You don't need to show the 1 times, so you could just go 3 raised to the k minus 1. Okay, so there's our summation notation. Now, how do I go about and find the sum? Well, to find the sum, you could just very quickly add those up in your head, and of course we would get this answer. Okay guys, that's all we're going to do for today. When you come to class next time, we are going to do a geometric series worksheet. So, in request of what Miss Oliver wants us to do, I would like to say sayonara.